Okay, 2.3, we are dealing with, oh, wrong color. We are dealing with synthetic division. So 2.3 synthetic division. Let me do a quick reminder of what synthetic division is. Let's say you had a function. Let's say the function is x cubed plus 4x squared plus x minus 6. And to find one of the factors or a root, we can use synthetic division. Let's say if we want to determine if -3 or x plus 3, right? -3 being the root, x plus 3 being the factor, is a zero of our our function. So what I'm going to do is I'm going to take my -3 here, and I'm going to put it into my synthetic division equation. So I'm going to use -3. I'm going to take the coefficients from each one in descending order, making sure if there's any that skipped, we would put 0 as a placeholder. So here, 1, 4, 1, -6. I'm going to go through the process. First, take the first number down, multiply it by -3, add. So 1 times -3, add -2, -2 times -3, we got +6, add it together, we have a 0 here, right? This would be my remainder 0. Since we have a remainder 0, that is a root of our equation. So now let's see how we can take our function to the next level here. Let's say, let's use the same equation that we have, but they want us to say, let's use the number -7, right? Let's say we're 1 -7, and they want us to put it into this format of f of x equals x minus k times q of x, right? Q of x plus r. Let's break this down into each part what this means. Well, the x minus k is going to be the factor of this. This q of x will be the remainder of the actual function. And then here, after we do the synthetic division, would be the remainder using synthetic division. So let's put this, try it now. So let's say we have -7 here. And just a little quick reminder, if we had a -7, right, our factor is not x minus 7. It would be x plus 7. So that we can know, we can already, knowing that, we can always put that in this equation here. So our k value would actually be -7, our k value being -7, and from our factor it is, our factoid is x minus 7. Okay, moving on. Let's go on to the synthetic division. We want 1, 4, 1, -6, just like the steps before, but this time dealing with -7. So 1, we have -7, add -3, 3 times -21, then we have 22. 22 times -7 is -154. Oh, let's change my color here. -154. So then I'll put it in the wrong space. -154. And -154 plus negative 6 will be negative 160. So this here is my remainder there, and we would write it as f of x equals x plus 7 times q of x. Q of x is this out here, and we'll go in descending order. So since this, the 22 would be a constant, the negative 3 would be our x, and the 1 would be our x squared. So this would be x squared minus 3x plus 22, and then on the outside plus our remainder, which is actually minus 160. So then that would be minus 160. So with that also in mind, so that's how we would do that. But let's go on to the idea now of our remainder theorem, right? A remainder theorem just basically says whatever the remainder is, if we put our number into the equation, whatever remainder is would be the same as, say, if we had put that actual number into our f of x. So if we put in f of negative 7, it should equal negative 160. That's what that means. So let's check that. So if we said x cubed plus 4x squared, right, plus x minus 6, if we put in negative 7 into each spot, and we worked it out, it should equal 160. So let's check that theory right now. So negative x cubed, let's see, negative x cubed is 343, so negative 343 plus 4 times what? 49. 4 times 49 is 196 minus 7 minus 6. So let's combine all that together. 343, negative 343 plus 196 minus 7 minus 6, and we got negative 160. So that proves our remainder equation, that this, if you would have just put it into a regular f of x. So our remainder equation just, theorem just says that instead of putting the actual number into our x, we could just use synthetic division, and whatever our remainder is will also be our value. So this and this are one and the same.